Let's start 7-3. So 7-3, we're now going to focus on the division properties of exponents. So we did the multiplication properties. That's the product property, power property, and the power product property. So now we're going to do the two division properties. So division has two of them. Division has two of them that we use. So we're going to start with the quotient property. So let me break my highlighter out. That way, those of you who didn't print it out, they know what to write. So that they know what's going to get checked. Quotient property. If you are dividing two items with the same base, here's the key thing. You're going to subtract the exponents. The key thing is you are going to subtract the exponents. So if you are dividing by the same base, you subtract the exponents. So let's do two examples of subtraction. So example 1, you have t to the 12th over t to the 5th power. So you're dividing with the same base. So you keep the base and subtract the exponents. What's 12 minus 5? Don't think that I'm necessarily looking at you all the time. I'm also looking at you. I mean, I'm appreciative of the fact that you said it.
So this is how I used to be in the old man class.
Then keep on going with it. See, look how smart you are. All you gotta do is remind yourself what you used to do. Oh, about that. So, t to the 7th power, that's your final answer. So, if you forget the property, here's why you should remember the property. T to the 12th means you have t written 12 times. Don't write this, please. 4, 5, 6, 7, 8, 9, 10, 11, 12. Divided by 1, 2, 3, 4, 5. So if you don't remember the property, then you got to write them all out and then start pairing them up. So these two pair up, I can cross them out, cross them out, cross them out, cross them out, cross them out. You count up whatever's left over. 1, 2, 3, 4, 5, 6, 7. I don't know about you. I'm not trying to write that out all the time. I'm not trying to write that out all the time. Besides, if Mr. Lowe is anything, he knows he is petty. He will gladly put t to the 20th up there just to see who knows what the property is. So you can either write it out 20 times, or you can know that the property what the property is. So, know the property. Don't let Mr. Lowe be correct. Okay. Example 2. So example 2. Okay, we put numbers in front of it. No. So we don't subtract the numbers. We divide them the way we normally do. So 45 you would still divide by -9. And then you still have m to the 13th divided by m to the 5th. So treat it like two separate things. 45 divided by -9 gives you -5. You're dividing by the same base. base. Subtract your exponent. So, for the folks at home, what's 13 minus 5? Minus 5. Everybody else, many people that know they got A, B, and C up in here. Thank you. Let's not quickly your life. Thank you. So that's quotient property. See, quick, simple, and relatively painless. Questions on 1 or 2? Questions on 1 or 2? Of course, when you are doing your notes, definitely make sure you got both the examples. So let's do the second property again. Division only has 2 properties. So this is the power quotient property. So if a fraction is raised to the same exponent, so you distribute the exponent to everything, and then you simplify it. So anything that is inside that fraction, you just give the exponent to it, and you simplify it. You give that fraction, give that exponent to everything. So 2/3 raised to the 4th power means, oops, I'm not using the highlighter anymore. So the 2 and the 3 will be raised to the 4th power. Now, of course, you need to work it out. If you need to use a calculator, you can use your phone if you need to, unless you have a calculator. You don't know where your calculator phone at?
Wait, oh.
It says so. So 2 to the 4th power, 16. 2 times 2 times 2 times 2. What's 3 to the 4th power?
Wait.
You did it 5 times.
Where's the 8? Oh, 81.
81. 243 is 5. There you go. Problem's over. 16 over 81 can't be reduced. Any questions? Example 3. So, example 4. How many things do we have inside the parentheses?
Yeah, 2 big,
We got 2 variables and
1 whole one.
one number. So how many things do we have total? 3. So we have 3 things inside. 2 variables, 1 number. So everything gets the exponent. So it does not discriminate. If it's a number in there, it gets it. If it's a variable in there, it gets it too. We are not going to discriminate. So 5 gets raised to the 3rd power. Y gets raised to the 3rd power. And Z gets raised to the 3rd power. So everything gets it. Everything gets it. So the only thing we have to do is to simplify. So y to the third is not going to change. Z to the third is not going to change. What's 5 to the third power? The only thing that changes is 5 to the third. It's not 15 either. 125. 125. That's it. Problem covered. All right. So questions. Examples 1, 2, 3, and 4. Let me give 30 seconds to anyone who still needs to finish copying. You got any questions on any of those 2 or 4?
Every time you do it. As long as I keep these, I'll be okay.
Well, you keep your notes.
Yeah.
See? Now you know what you do. It's not like you forgot how to do it. But it's not like you've never been a good student. Never been a scholar. You've always been it. Now just getting back to what you used to. All right. So let's look at these next 4 examples. So the next 4 examples, now we kick the degree of difficulty up a little bit. So we either have more variables, we're using more than one property, we kick the level of difficulty up a bit. So let's start with example 5. So example 5, what do you notice? What do y'all notice in this problem? How many different letters do you see? Start with the letters. How many different letters do you see? So we have 4 letters, 2 of the same letter. And we have numbers, coefficients sitting in front of it. So if you see a problem set up like this, there's nothing that says you can't break it apart. Take the numbers, work with them separately. Take the A's, work with them separately. And take the B's, work with them separately. Everything we work with separately. There's nothing wrong with that. We're working with them separately. So let's solve it out. 54 divided by 9 is what? So it'd be nice to eventually hear from someone that's not female. There are a lot of males in this class. Well, I ain't gonna complain one way or the other. So 54 divided by 9 gives me what? I know you do. Let's see, 54 divided by 9. I know Morgan Parker knows this. Okay, Dion knows it. I don't care if you're on your phone. Y'all can answer a question. The other males that we start calling them out one by one. So that's Daniel, LaRon, Mikkel, Clyde. Let's see. Who else popping up on my feed real quick? Let's see. What's 54 divided by 9? This ain't that difficult. 6. There you go. And some of y'all, don't let the only time that y'all speak up about something be, Mr. Lowe, what can I do to fix my grade? Because I'm going to go to all the times where you didn't open your mouth. 54 divided by 9? 6. So I'm dividing with the same variable. So what do I do with the exponents? You subtract them. 8 minus 5 will give you 3. And then you do the same thing with the b's. 6 minus 4 it gives you 2. That's it. Problem over. Again, don't not speak up because you're afraid of being wrong. The only person that's good enough in math to talk about anyone else in this class is me. They don't want me to talk about it. They're not ready for this life. Well, at least you know I'm the same person with you sitting here that I am when y'all at home.
I'm just trying to be awkward. It's not awkward at all.
Why? Because I'm being me.
Check from my other teacher. I just thought it was going to be awkward.
I certainly just genuinely miss y'all. We all like teaching. It's just hard teaching in an empty classroom. Yeah, some of y'all work out early. Y'all work out our last nerve, but we still love you. So, example 6. What do you notice is an example 6? What do you see in example 6? What's just blinking, glaringly there? What are those things called? Parentheses. You see parentheses, that means for division, you're going to be distributed. How many bases are inside the parentheses? How many bases are inside the parentheses?
2.
More than 2. Less than 4. So a base is anything that's not an exponent. So the 2 is an exponent. So that means 2 is a base, x is a base, and that y is a base. That 2 is an exponent. So you have 3 different bases. So you have 3 different bases. You're going to give the 4th power to all of them. So 2 to the 4th power, x to the 4th power, and y squared raised to the 4th power. So we distribute the exponents, and now we're going to solve it out. So let's start with 2 to the 4th. What's 2 to the 4th power? To the 4th power. A number. It's not 8. 2 to the 4th power? Two raised to the 4th power. That's 16. Daniel, I don't know if you said 16, but it is 16. It didn't come out clearly, that's why I kept searching for it. X to the 4th stays x to the 4th. So, I can't keep those 2 exponents. I have to do something with them. So what can I do with those 2 exponents? Multiply them. And guess what? That's what we did yesterday. Now we're combining what we did yesterday and today. Now we're combining them. Now we're combining them. That means what we did yesterday can also be used today. And it's going to be used today. Questions, example 6. Question on example 6. Again, remember, those of you taking notes at home, every example gets checked. Every example gets checked. So example 7. We've got 6h to the third times 9h to the seventh divided by 18h to the fifth. So, which part of the fraction looks harder, the top or the bottom? Which part looks harder, the top or the bottom? So let's work out the top first. Let's work out the top first. We're going to simplify the top of the fraction first. So we have 6 times 9 and h to the third times h to the seventh. So what could I do with 6 times 9? What's 6 times 9 equal to? $54. So we're going to put 54 up in there. 6 times 9 is 54. And we're going to take h to the third times h to the seventh. So we're multiplying with the same base. So what do we do with the two exponents? What do we do with the 3 and the 7? So we don't multiply them. The only reason I put them in parentheses was to separate the numbers from the h's. Add them. So we add them. So this ends up being 54 h to the 10th. And we still have the bottom of the fraction. So, I'm assuming that was you that asked the question. So, the only time that you're going to multiply exponents is when you have an exponent sitting directly next to an exponent. That's multiplying. That's the situation where you would multiply exponents. When you have an exponent directly next to an exponent. Oh, don't box that up. We ain't done yet. So, this ain't our final answer yet, though. We still got to do 54 divided by 18, and we got to take care of the h's. So, 54 divided by 18 gives us what? 3. That's 3. And then we have to take h to the 10th divided by h to the 5th. So when we're dividing, what do we do with the exponents? So what are we going to do with the 10 and the 5? Subtract them. 10 minus 5? 5. 10 minus 5 is 5. That's it. Problem's over. Not a hard problem, but it does require you to know how to work the problem. Don't you all who play a sport. Guess what? If you don't know how to run the plays, you ain't playing. That's simple. If you don't know how to run plays, they will not play you. So now let's look at 8. Now 8 looks like it's real hard. It's not, but you just have to know what you're doing. How many fractions do you have? 2. If this was your problem, how would you have solved that out? 1/2 times 3/4. What would you have done? Now cross multiply. You're going to multiply. but not cross. Cross means 1 times 4, 3 times 2. How would you have multiplied those two fractions? If you can multiply this, you can multiply that. If I was doing 1/2 times 3/4, what would you have done? Because you have to know how to do that in order to solve that problem.
Yeah.
That's the first honest thing I've heard today. It is okay for you to say, I don't know, or I forgot. Too many of you all are real worried about being wrong. Guess what? The only one that can talk about you is me. If anyone else talks about you, then I'm going to talk about them, and they're not ready for this life. If you had 1/2 times 3/4, you would multiply from left to right. 1 times 3, 3. 2 times 4, 8. You do the exact same thing to example number 8. You're going to take 2x squared y times 9y, 9xy to the square. So you're going to take the top and multiply them together. Take the top and multiply it together. So you have 2 times 9. What's 2 times 9? 18. Now let's deal with the x's. X squared times x to the first power. So that means you have to add the exponents. What's 2 plus 1? Good. Y times y squared. So y is raised to the first power. 1 plus 2 is 3. So now the top fraction's taken care of. Top fraction's taken care of. Not that hard. Now let's do the bottom fraction. Someone came off mute. You got a question to ask. I'm not going to not answer your question. So 3x times y to the 4th. So 3 has nothing to multiply by. X has nothing to multiply by. And y has no one to multiply by. So I guess they all just move over. They all just moved over. Any questions before we continue? Sorry, you got any questions before you go ahead and move on? And again, there you go, boxing up the answer. It ain't done yet.
Yeah.
I didn't say we was done yet. So, one thing to help you, because I know some people will box this answer and think that they're done. You're not finished if you still see more than one of the same letter. So you shouldn't see X more than once. You shouldn't see Y more than once. If you see it more than once, that means you got to do something with them. You're either going to add the exponents, subtract the exponents, something. But you only want to see that letter once. So think about that when you're doing your work before you box anything up. If you see that same letter more than once, you're not done. So, we have our problem. 18 divided by 3, the x's go with the x's, the y's go with the y's. 18 divided by 3 is 6. When you divide, you subtract the exponent. So what's 3 minus 1? 2. Same thing with the y. So what's 3 minus 4? Negative. Negative 1. So negative 1. Now, for right now, this is our final answer. There is a property that goes with negative exponents, which we will deal with next week. There is also a property that deals with what happens if you have something raised to the 0 power. Notice that those are the only two numbers we haven't touched yet. A 0 exponent and a negative exponent. Those are things that we will deal with next week. Right now, we're getting the main properties in. If you can't deal with 0 or negative until you know the main properties. Once you get the main properties real good, then we can deal with 0 and negative. So, any questions? Example 8 before we get ready to wrap this on up. So, y'all did some good work today. Heard a lot of good questions answered, or a lot of good questions asked. My Rudy up here helped out. So, examples 9 and 10 are just like examples 9 and 10 from the first one. I will work those out and post it to Google Classroom. So, let's see, not that one. So finally, let's look at examples 9 and 10. So 9 and 10 for division, for this notes page, is very similar to 9 and 10 from the multiplication notes page. Now we're finding missing values. So this is where you truly need to know how to use your properties of exponents to find missing values. So for example 9, you have w to the question mark power over w squared equals w to the 8th power. So this is a direct application of the fact that if you're dividing two things with the same base, then you subtract the exponents. So if you use the formula with this problem, you have the same base, so you take the exponents and subtract them. Question mark minus 2 equals 8. So that means x minus 2 equals 8. And then it becomes a basic equation. Add 2 to both sides. So x equals 10. So that means that exponent at the top has to be 10. The exponent at the top has to be 10. So now let's switch it around and do problem 10. Problem 10, same principle applies. This time we're using the other property, which is if you have a fraction raised to the same exponent, you distribute that exponent. So notice in this problem you have 4 y squared and a 3 all being distributed to an exponent that we don't know. So we have 4 to the question mark power, 4 question mark y squared question mark over 3 question mark equal to 64 y to the 6 over 27. So the main thing here, since there are 3 different parts, you're going to have 3 different equations. Since you have 3 different parts, you're going to have 3 different equations. So 4 to the question mark has to match up with 64. So that's 4 question mark equals 64. So 4 to some power is going to give you 64. the y's have to match up with y to the 6. So that's y squared question mark equals y to the 6. So y squared raised to the x power is y to the 6. And then finally, 3 to the question mark equals 27. So that means 3 question mark 27. 3 to some power is 27. Now, main thing to keep in mind, whatever this exponent is, whatever x is going to be, it has to work for all 3 of these equations. It's got to work for all 3 of them. So you can pick any of the 3 that you want to work. So you can try to figure out 4 to what power is going to give you 64, 3 to what power is going to give you 27, or you can work with the middle equation. Either way it goes, x equals 3, because 4 to the 3rd power is 64. 3 to the 3rd power is 27. You just have to make sure it works for the middle. So remember, if you multiply, if you have 2 exponents next to each other, you have to multiply them. 2 times x is 2x, which has to equal 6. Divide by 2, so x equals 3. So either way it goes, the missing exponent, the question mark equals 3, x equals 3. So that missing number is 3. So again, all of that comes from an application of the actual exponent. The application of the actual exponent. So with that being said, that completes the notes page for 7.3, using the division properties of exponents. So on our next class day, you'll be doing a review of all of the properties of exponents, the multiplication properties and the division properties. So have yourself a great rest of your day. Ask questions if you need to, and I'll talk to you soon.